Welcome everybody. I wanted to give you a demonstration here of some solids, liquids, and gases, and maybe a different way of kind of visualizing them. So what we see here is the three main matter phase types, or if you were thinking phases of matter or states of matter, all that's perfectly well and good. You can use those words interchangeably. There'll be times that I say phases of matter, there'll be times that I say states of matter. It's really just kind of referencing, at least for Chem A Unit 1, a solid, a liquid, or a gas. So this should be something you're familiar with, right? They're ice cubes. So these are the solid form, or I should say this particular guy right here, right? This is the solid form of H2O, or the solid form of water. So you should be at a spot where if I said, all right, this is a solid, how are we going to describe this? I'm not asking you how to describe ice, where you might say it's cold or something to that effect. If I say that this is a solid, or this pen is a solid, the way that I want you to describe them as we're working through this first unit is in reference to its volume and its shape. So by volume, what I mean by that is how much space does it occupy? So I get that over time, each of these ice cubes will slowly but surely melt and undergo a phase change or enter a different state of matter. But we're just going to talk about the ice cube as it is right now. So the space that it occupies, or its volume, is set. The volume of this pen is set, or sometimes we'll say it's fixed or it's definite. It basically just means that it's not going to change. The other thing that we use to describe our phases of matter or states of matter is the shape. So if I'm going to call this a solid, that would mean that it's got a fixed or a definite or a not changing volume and shape. So sometimes we don't have a solid, but we've got a liquid. So this was an 8-ounce bottle of water, minus the sip that I took earlier. So if I'm looking at this, I mean, not the bottle itself, but I'm actually referencing the water that's inside. The volume, or the amount, you can kind of think of it as the space, the volume or the space that this liquid water occupies in this bottle, it doesn't change. But, you know, it shouldn't come as a big surprise. It's a liquid, right? As I move this around, the shape does change. So there it's kind of a little bit more cylindrical, and then there it's going to be a little bit more flat. If I were to take this bowl and take this water and I pour it in there, the volume or the amount of water that I've got in this bowl, it's the same as what I had in this bottle. And if we look at the shape, it's changed. So what we're getting at here is when you've got a liquid, we would say that the volume or the space of the substance, it's set or it's fixed or it's definite. But the shape, it just takes on the shape of its container, which means that it's not set or volume or definite or however you want to describe it. So some kids might say, well, now this water bottle is empty. I would argue a little bit differently. I would say that there is something in this water bottle. And some of you are probably understanding what I'm getting at here. There's air. And in the air that we breathe, it's a mixture of things that we'll talk about later. There's a lot of nitrogen, there's obviously some oxygen, there's some carbon dioxide, some argon, some other little trace gases, but there's also water vapor. So there's water vapor in the air that we breathe. On a real humid day, you may notice that there's more water vapor than normal. On a dry day, I like in the wintertime as the air starts to dry out, your skin maybe gets a little bit itchy. That's because it's drier. There's less water vapor. So we can't see the water vapor in this bottle or the water vapor that is in the air around us. So what that means is that you can't see gases. So here's something to kind of think about. All right. There's you, and you're enjoying a nice day. And you look up, and you see some nice big billowy clouds. You can see these clouds. Now, a second ago, I said you can't see water vapor. So if you can't see water vapor, you can't see gas, water gas, but you can see clouds. Are clouds water vapor? This is something we'll discuss a little bit later. But what I want you to kind of get on the track of thinking is, no, if you can see clouds, they aren't water vapor. They're not gases. They're actually little bits of solid or little bits of droplets. And we'll talk more about that in class, but it's something kind of fun to get into. So what are we going to do for our little demo for the day? That part should have been sort of review, looking at ice cubes and water vapor and liquid water, and we should be good with how the volume is set or not set, and the shape is set or not set. But what I've got here is a little glass mixing bowl, and these little guys here, they are actually little clay. They're made of clay. They're for my slingshot. So, I can use these for ammo with my slingshot. But we're going to pretend that they're not little clay balls for slingshots. We're going to just kind of pretend that they're atoms. And as atoms rearrange, whether I look at an ice cube or I look at liquid water or I look at water vapor, that's H2O, H2O, H2O. Or solid water or liquid water or water gas, water vapor. It's all basically just water, but it's in a different phase. So how those atoms, the H2O is arranged, basically gives us that state of matter or that phase of matter. So we're just going to pretend that these are atoms. And this is our little space or volume, right? And I'm going to try to mimic the motion of those atoms. So I got a few in here, right? And notice that as I just give this a little swirl, they're moving free and far apart. Sometimes they collide with each other. Sometimes they collide with the wall of the container. But just with this little shake here, they're moving pretty quickly. I want you to think about what phase of matter or what state of matter would this best represent. So I'm going to change something here. I'm going to add in a few more atoms. And I'm going to do the same little shaky shake. I'm going to add a few more here. So with this little bit of shaking here, you notice that their motion, the speed, the collisions, they change a little bit. So if I've added a few more here, I want you to also think about, well, what phase of matter does this represent? As I'm looking at this, some of the things I observe, the little particles, my little atoms, the little clay ammo balls here, they kind of slide past each other a little bit. And if I were to add some more particles, I'm giving it still a little shake, and listen carefully. We still hear a little bit of movement. If I look at them, there's some wiggle there, but they're not really moving as much. So what would this represent? Basically, I've got a lot of atoms that are in a tightly packed area here. And with this little bit of wiggle, there's some vibration and some movement, but not really a whole heck of a lot. And as I start to, losing these guys, take some out, I get a little bit more fluid motion, where they can kind of slide past each other, but they're still kind of contained within here. And if I were to take out a few more and I watch their movement, now they're pretty free and far moving. Looks like there's a lot more speed there, even with the same little bit of wiggle. So I will say that as we get further into the course or further into the topics, this isn't a perfect example of looking at the differences between solids, liquids, and gases, but maybe it's kind of a visualization for you to begin with. So we're going to refer back to this, but what I'd like you to do, now that you've watched this video, is to grab the phases of matter demonstration written response and read through that, and I'll explain that a bit more, what you need to do. If you have questions, feel free to email. Until we meet again,